Assalamualaikum warahmatullahi wabarakatuh. How are you? Okay? All right. Okay, good. Okay, today we are going to finish up the Lagrangian multiplier. Then we will discuss the midterm. Because today is our last class, right? Today last class. So I will finish up the Lagrangian. We look at application, and then we will discuss the midterm. So this is where we left last time. We have the method. So I think what I will do, I will finish up this thing here. When you have solve, x in terms of y or y in terms of x, and then you substitute into the equation number 3, which is L lambda, then we will get the optimum value of x and y. So let's finish this up. So let's say you substitute x equal to 2/3y into number 3. What is number 3? 2x plus 3y minus 70. So 2x plus 3y. So 2x. So now 2x is 2/3y. Okay, plus 3y. 3y minus 70 is equal to 0. So now we have everything in terms of y. We can solve for y. So that is 4/3y plus 3y equals 70. That is 4/3, 9/3, 9/3, 13. 13/3y equals 70. And y is equal to 70 times 3/30. So that would be equal to, okay, if you have calculator, you can determine the value, which is equal to what? 70 times 3 divided by 13. 16.15. 16.15. So y equal to 16.15, then you can get x. So to get the x, okay, to get x, then we substitute y equal to 16.15 into x. X equal to 2/3y. Okay, and then equal to 2/3, 16.15. And that is equal to, if you multiply that, divided by 3, 10.77. 10.77. Okay, so that is the solution. All right, so that will be the optimum value of x that solve the problem. Now let's look at another example. I'll go to example number 1 in 14.5. So let's see example number 1. So if you look at example number 1, what do we have? We have to maximize the value of the function subject to the constraint. Apa dah? Anything? Apa dah? Okay. So for that thing here, you write the objective, not objective, the constraint. Okay, the constraint which is the constraint given x plus y equal 9. So you rewrite, okay, rewrite that x equal to y, I mean x plus y, x plus y minus 9 equal 0. So now that is our constraint. So you have the Lagrangian equal to what? Equal to the objective plus the lambda multiplied by the constraint. So putting the functions, the objective and the constraint, you will get x squared y plus lambda multiplied by the constraint, which is x plus y minus 9. So that is our Lagrangian function. So to get the partial derivative, we take the derivative Lx. So what do you get? The derivative, the first thing here is x squared. So you got 2xy plus lambda. Okay, that equal to 0. So call it number 1. And then you got L lambda, that is equal to x squared plus lambda, that is equal to 0, number 2. And then L lambda, you got x plus y minus 9 equal 0, number 3. So, like I said earlier, you use the method from 1 and 2, right? 1 and 2, you will, what do? You will get x in terms of y. So if you use 1, what do I get? I get lambda equal to negative 2xy. And then from number 2, what do we get? You get lambda equal to negative x squared. So therefore, they are equal, okay? Negative 2x squared is equal to negative 2xy equal to negative x squared. Now, for negative and negative becomes positive. So we got x squared minus 2xy equal 0. So you factor out the x. Then what I get? I get x minus 2y equal 0. So either x equal to 0 or you have x equal to 2y. Okay. And then x equal to 0, tak ada apa. X equal to 0 is nothing. All right. If you put x equal to 0, then y equal to 9. All right. So I don't think that would be the solution because you have another value here, x equal to 2y. Okay. So if you use x equal to 0, then you get a solution or y equal to 9. But x equal to 0, if you look at the graph, okay, if you look at the graph of something like this function here, you will see that the optimum point, okay, if you look at the graph, you f of x y equal to x squared y. Okay, the graph look something like this. Okay, and then the objective is a linear function. Look like that. So if you have, right, if we have x equal to 0, then the point will be somewhere here or here. We don't know. But if you put x equal to 0, you got y equal to 9, that will be here. Okay? So that is not the optimum point. The optimum point will be somewhere here, where x is bigger than 0, so y bigger than 0. We take the value of x equal to 2y. Right? You take x equal to 2y. And then what we do, you put into number 3. Okay. All right. So x equal to 2y, substitute into number 3. X equal to 2y into number 3. Do I get? Equal to number 3. X plus y minus 9 equal to 0. So you got 2y plus y minus 9 equals 0. 3y equal to 9. So therefore, y equal to 9 over 3 equal 3. So y equal to 3. Now, when y equal to 3, then what about x? X equal to 2y. That will be equal to 2 times 3 equal to 6. So we get that by what? By substitution. Okay, so that is how we solve the problem. So that is example number 1. So I think we did already enough example. So now we look at application. Okay, application, we look at 2 applications. Example number 4, example number 5. So both applications are economics application. So first one, you maximize utility. That is objective of the consumer. You maximize utility, but the constraint would be the budget line. Or, in other words, you maximize utility given our income. Okay, budget means income. So given our income, you want to maximize utility. So that will be our example number 4. So example number 4, you maximize utility. Okay, maximize utility subject to the income constraint. All right, income constraint or budget lah. Okay, or budget constraint. Okay, now in terms of the diagram, you can look at figure number 4. So look at figure 14.13. So if you look at figure 14.13, the budget line, okay, the budget line here, the income line, is a linear function. Okay, linear function. The utility function is non-linear. Okay, here is non-linear. So most of the time that we look at our application, or generally in the Lagrangian multiplier, you will have, okay, for at least as far as we are concerned, you have either the constraint is linear, okay, the objective is non-linear, or, all right, or we may have the objective is linear, the constraint will be non-linear. So either one, all right? Either the objective is linear, constraint will be non-linear. If the objective is non-linear, constraint would be linear. Okay? So if you look at figure 14.13, that problem will be something like this. You have the budget line, straight line. Okay, that is our budget line. And then the utility function will be like this. So the solution over here. Okay. Solution actually if you look at the figure, the book, it should be touching. So we call that point E. I draw it. It's not, my drawing is not as good. So you have call it X star, Y star. So X star, Y star is the optimum point. E. So there will be X star, Y star. That is the point where you maximize your utility. X squared plus y, the function given. Now x squared, y squared, given the budget line 2x plus 4y equal 40. So that's point. The point, okay, at that point, you will see that the slope of the budget line is equal to the slope of what? Slope of the utility function. So the slope are equal. So by making use of the Lagrangian, we actually solving, okay? Solving the solution or the optimum point where the slope of the two lines are equal. But we are going to, we did it by what? By the Lagrangian. So that is a graphical presentation of the solution. Okay, all right. Now, if you look at the budget line is linear. So budget line linear, it is in the form of what? Let's say budget line, call it I, the income, that is equal to simply AX plus BY. Or before we do that, we just look at the general form of the linear function. AX plus BY equal to some constant, okay? A constant equal to AX plus BY. And then for the budget line, that constant K is the income. And that is equal to what? That is equal to the PX multiplied by X plus PY times Y, where I is the income or the budget. The X is what? The X is the price of X. And then PY is the price of Y. Now, all this fixed, okay? They are fixed, they are constant. So if you look at the diagram, I'm sorry, not the diagram. If you look at the example 4, you are given the budget, all right? 2x plus 4y equal 40. So how much is the income? If you look at the budget line, what is the income? Hello? Ada orang ke tak ada orang ni? Income berapa? What is the income?
$40.
The income is 40. So we have to go back to benda ni lah. I already defined, okay, what is the budget line? The income is equal to the price of X times X plus price of Y times Y. So the income is 40. The price of X is 2. What is the price of Y? 40. So sometimes, you know why I do this? Because sometimes you are not given the budget line. You are given the prices. Okay, you are given the prices. So what you do, you have to develop or you have to come up with the budget line. And it's easy because the budget line is the linear function. All right. So let's say, okay, if you look at some of these examples in this type of thing, some of the questions, they say subject to the budget line, given income, okay, income is 200 RM. And then the price of one good X is 10 RM, or not, maybe the price of X, say 3.5 RM, 350, and then the price of Y is equal to, say, $7, 7 ringgit. So they don't give you the budget line. They give you the income and the prices. So you have to get the budget line. So how do you get the budget line? We know the budget line is a linear function. I equal to PX X plus PYY. So put in everything that we equal to 200 equal to 3.5 X plus 7Y. So that is the linear budget line. Okay, all right. So the constants, okay, the constants are the income, which is the constant. And then the other constants, the coefficient of X and Y, they are the prices. Okay, all right. So go back to the example. The Lagrangian, all right, the Lagrangian would be equal to what? You write down the Lagrangian. The Lagrangian is equal to, I have the problem here, maximize utility given the budget line. So you have to rewrite the budget line. So I put in the Lagrangian first. Okay? L is equal to f of xy plus lambda multiplied by the constraint. Okay. Now, what is that equal to? So you have to go back to the budget line. Okay, so go back to the budget line. You have to rewrite the budget line. Rewrite x 2x plus 4y equal 40 as what? As 2x plus 4y minus 40 equal 0. So you have to rewrite in that form. Okay. That is the required form in the Lagrangian function. So now you have everything. You come up with the Lagrangian function. So the Lagrangian function is equal to, put in the values of the functions, the respective function. I have x squared, y squared, utility, plus lambda equal to what? 2x plus 4y minus 40. Itu dia. Okay, so we take the partial derivatives. Then you got Lx equal to, what is it? You have x squared here, okay? So we 2xy squared plus lambda 2 equal 0. Call it number 1. And then I got Ly equal to, you have y squared, so x squared 2y plus lambda 4. So if you are not sure how to do this, so you multiply everything by the lambda, okay? Comes in the bracket. So I got what? I got lambda 2x, and then plus lambda 4y minus lambda 40. If you do that, you will not miss, okay? You will not miss, and we'll be able to do the partial. And set that equal to 0. And then thirdly, I got the L lambda that is equal to 2x plus 4y minus 40 equal 0. That's number 3. So like we do earlier, that is our method. You use 1 and 2, write lambda in terms of x and y. So from number 1, what do I get? I get lambda 2 or 2 lambda is equal to negative 2xy squared. You bring the 2 to the left. I got lambda is equal to negative 2 over 2 xy squared. So 2 and 2 cancel out. And then we do the second one. So from number 2, you got lambda 4 equal to negative x squared 2y. Lambda is equal to negative x squared 2y over 4. So that cancel, you got 2 here.